Okay, so Hariharan, let's
Yeah,
start with your orals. We'll start
yes,
with function 4 first, and then we will
yeah,
move to function 6. Okay?
yeah, sure, sure.
Okay, so what kind of vessels you have done?
I have done container ships.
Container vessels.
Yes, sir.
Okay, and what was your engine type?
ME, sir.
Okay, can you give me the specification for your engine?
I said 10K 96 M ME engine.
ME?
Engine.
That's all?
Yes, sir, that's all.
10K96 ME? That's all?
Yes, sir, 10K 96 ME
Is
engine.
it not MEB, MEC, something like
No,
that?
sir. No. Fully ME engine, sir.
Okay, can you give me the complete specification for this? What does 10 means, K means, 96
Yes,
means?
sir. 10 stands for number of units, I mean cylinder.
Okay.
Stands for ultra long strokes.
K stands for ultra long stroke.
Yes, sir.
Okay.
96 cylinder bore dia.
Okay.
Electronic engine.
Electronically controlled.
Yes, sir, electronic engine.
So, do you know what is the difference between MEC and MEB engines?
Yes, sir. A MEC means it's a compact engine, sir. So, which means the overall length of the engine is reduced by 1:10 ratio.
Okay.
And some of the parts are like unit is nearby near units. And like that, sir, in MEC. And ME engine is normal electronic engine.
MEB engine. MEB and
Sorry. MEB engine is in MEC engine, like all the components are controlled by hydraulically.
right.
Yes, sir. In ME engine, except what to this exhaust valve action, all others were done by hydraulically, and exhaust valve is alone actuated by camshaft.
Yes.
Hmm.
Correct. So exhaust valve is camshaft actuated, camshaft
Yeah.
control.
Yes, sir.
So the problem right now is to clearing MEO class for all 6 writtens and 4 orals ASAP, because you cannot go on shift till the time you do that, and I understand the pressure. So right now how I can help you is, guys, please go for this MEO class for live classes that we have started. I guess there'll be amazing results awaiting you. Apart from that, if you are worried about how will you perform as a fourth year, third year onboard shift, why don't you invest on fourth year, third year excellence package, which is again available on Merchant Navy Decoded platform. ये जितनी चीजें आप ही लोगों के लिए बनाई है, I am waiting that you achieve success and I achieve damn good results. Take care. Bye.
Okay. So, what about your auxiliary engine? What kind of auxiliary engine have you worked on?
Yes, sir. Daihatsu.
Daihatsu. Do you
Yeah.
name? Can you name the specification of your engine, auxiliary engine?
Yes, sir. 6S
Okay.
48 MC engine.
MC.
Yes, sir. MC.
Okay. 6S
Yes,
48.
sir.
Okay. Can you give me the specification?
Specification in the sense like.
Like you have elaborated the main engine, no? So,
Oh, okay. Yes, sir. 6 cylinder,
yes.
a short stroke,
Mhm.
48 bore dia.
48 centimeter, yes.
Yes, sir. And MC engine, like mechanical camshaft engine.
Mhm. Okay. Now, moving to
Hmm.
what do you understand by a crankcase explosion?
Yes, sir. Understand. Like crankcase explosion is one of the major engine faults, sir. Like in the crankcase area, there are a lot of oil mist particle will accumulate over there. Because of the mist particle, like, and also we are maintaining the crankcase level under lower explosive limits. So like if there is a formation of hotspot,
Mhm.
this formation of oil vapors will go in contact with the hotspot area. It will lead to primary combustion. So because of this primary combustion, there are a lot of cracks will happen inside the crank case area. Like for example, in the cracks in the crankcase A-frame, crankcase door, etc. And through the cracks, oxygen will enter through the crack and it will lead to secondary combustion. So
Secondary
these
explosion.
enormous, Yeah, secondary explosion. So these explosion will lead to explode very huge as a particle. The main engine will explode due to that. So in order to protect from this device, we are having ODM like oil mist detector, crankcase relief door, and breather. These are the thing. Bearing monitoring temperature. These are things.
Oil mist catcher box through the breather pipe, where
Yes,
your
sir.
oil mist will go and accumulate. But the question is, how does this oil mist formation takes place?
Oh, yes, sir. Due to high
Or the
temperature,
hotspot, how the hotspot and oil mist formation takes place?
due to high temperature,
Okay.
so insufficient cooling. So in insufficient cooling we are providing. So by this high temperature, the what are the oil particle will accumulate over there. No? So it will get evaporate automatically,
Mhm.
and through this
Okay,
evaporation,
can you
like,
give me the reason why this high temperature is taking place? Ineffective cooling, you are saying.
yes, not only ineffective cooling, it is one of the reason,
Mhm.
and another more reasons are like improper maintenance. For example, bearing clearance or not.
Correct. Okay.
Yeah.
Bearing clearance has reduced. So
Yes, sir,
bearings
reduce.
are rubbing. So bearing
So
is
yes,
taking
sir, friction will take place.
yes, friction is
Friction
taking
will take place. So the temperature is increasing.
rising. So that's why hot spots are formed in the
Of
bearing
course.
area, clearance area. Liquid
Yes.
temperature will rise. Right.
Yes. Yes.
Okay. Okay. Your next question is,
Yes.
so what types of pumps are there on board?
Uh, by principally theoretically, like rotordynamic pump, positive displacement pumps, sir.
Okay.
And I have seen like in rotordynamic pump, centrifugal pumps using a lot of places. And in positive displacement pump, gear pump, I have seen screw pump, I have seen reciprocating type pump, I have seen piston
So
type
can you
pump.
give me with examples ki which all pumps are there?
Yes, sir, of course. Like in centrifugal type, we are using in main seawater cooling pump, freshwater cooling pump, engine jacket water cooling pump, in freshwater generator, heat pump, and distillate pump we are using, and ballast pump, healing pump, bilge pump, emergency fire pump. These pumps and all comes under we are using as centrifugal pumps, sir.
Correct.
And in positive displacement pump, we are using piston pump. We are using for sludge displacement for a sludge purpose, and also we are using a screw pump as a sludge transfer pump. And gear pump we are using for heavy fuel oil transfer pump, diesel oil transfer pump.
Correct.
This, yes, sir.
Okay. So can you explain me the procedure of starting a centrifugal pump?
Yes, sir. Actually, by theoretically, we are saying that we have to shut the discharge valve of centrifugal pump, and we have to line up the system. And to ensure priming is, if there is no priming, we have to do priming by opening the priming cock, and we have to fill the water manually. But on board a ship, like a centrifugal pump is always in positive suction head, so no need of these things. Like just checking the lineup, and we are starting the pump
But
manually.
have you seen a self-priming unit being attached with the centrifugal?
Of course. Yes, sir. Yes, is there.
There is a
Is that like,
self-priming unit.
yes, sir, it is there, sir. With that shaft, there is a self priming unit is
So
there.
where else also you have seen? Have you seen it in emergency fire pump?
Yes, sir. I have seen in also emergency fire pump and main seawater cooling pump also in my ship it is present.
Yes. So that is the priming requirement, that so you don't need to shut your outlet valve or discharge
Yes,
valve
sir.
in this case, because you are fitted with a self-priming unit, which is already
Yes, sir.
in positive end.
Yes, sir. Yes.
Okay. Okay. Now, so you have done a container vessel, right?
Yes, sir. Of course.
Okay. Any engine maintenance job you have carried out on board?
Yes, sir. We have did exhaust valve changing and decarb of several units and piston stuffing was. Actually it may comes under decarb in a unit.
Mhm.
And
So can you give me the process of decarb of one unit, main engine unit?
yes, sir, I will give you. Like first of all, we have to if we are going to start a decarb of a unit, we need to get immobilization certificate from the port authority. So after we are getting approval, we are going to conduct the toolbox meeting, safety aspect and sensors. First, we have to ensure that our safety and machinery safety, we are getting ready. And for a major problem, I mean, coming to the work point, uh, we are going to isolate several systems, like for example, jacket cooling water system, and fuel oil system of the particular unit, what we are going to work in, I mean, deep furnace. So lube oil system, we are going to isolate the air system, and these four system we are going to isolate, and we are going to remove the exhaust valve like by using hydraulic jacks and nuts. We are going to by using crane, we are going to remove the exhaust valve, and after exhaust valve has been removed, like so crankcase door, that stuffing box area, there are some bolts and nuts were there that we have to remove, and piston foot bolt connecting with the connecting rod that we have to dismantle. And after that, like we have by using cranes, we are going to that clamp bolt we have to mount on the piston. By the time piston was in the top
Cylinder
TDC
also you have removed. Okay.
yes, sir, TDC
Exhaust
position.
valve removed, cylinder head removed. Okay.
Yes, sir.
Exhaust
So
valve
that
with cylinder head you have removed. So piston is exposed. Now you are removing the piston. So you have
piston.
from the inside the crankcase you have opened the bolts. Okay.
Yes, sir. Yes, sir.
Bolts.
Yes, sir. By through the way, by using crane, we are going to remove the piston away. Taken up that flame ring will be there. Mainly that flame ring top the cylinder that we have to remove. Oh,
It is not
after
called
that.
flame ring here. It is called anti-polishing ring.
Oh, okay. Yes, sir. Polishing ring. So that we have to
Flame
remove.
ring is actually in the auxiliary ring.
Auxiliary ring. Sorry, sir. Sorry.
Okay.
And
So that anything else?
uh,
Now what all you do when you have removed the piston. Now what all you do?
in the piston, I mean, we are going to concentrate on pistons sir, first. The piston, we have to remove that chrome thickness, like how much carbon deposits are there, and the chrome area, that calibration scale were there. So we have to place on the top of the piston, and wear down rate, like how much piston that mnemonic alloy, I think. So how much it was burned away that we have to measure, and all the piston ring clearance we have to measure, and that wear band position. So these are the top appearance of the piston skirt area, the crown part, those things we have to inspect and measure the clearance of those parts. And after that, we are going to remove the piston. Like we are going to remove the crown area of the piston and stick the seal, like that O-rings inside the piston. We are going to check, and any accumulation of carbon particles, those things we are going to check, sir. And after that, after everything
What
has
all
been checked
clearances you will measure?
in piston, sir, piston ring. Yes, sir. Butt clearance, axial clearance, and butt axial radial clearance. So,
How do you do that?
axial clearance we are going to measure by using feeler gauge, and butt clearance we are going to use vernier caliper, or else we are going to do by using impression method, like
Impression.
paper impression method we are going to do. And this one, the radial clearance is measured by depth of the piston ring groove minus the thickness of the piston rings. Yeah, by the way, we are going to measure these three clearance. And also we are going to inspect liner. Inside the liner calibration you can done using the horning marks and oil retention marks. Oil ports are clear, carbon deposit over there, and that flame ring we are going to clean it, and those area we are going to inspect, and scavenge ports, all those area we are going to inspect inside the liners.
Okay. Now let's move to MEP part. Okay.
Yes, sure.
Now, can you tell me what is a boiler blowdown procedure?
Boiler blowdown procedure. Yes, sir. I'll do. Boiler blowdown procedure is to actually there are two blowdown procedure are there, sir. Like one is for bottom blowdown, and another one is for scum blowdown. This bottom blowdown we are doing for sediment which are settled at the bottom of the boiler. So like dissolved salts, sludge particles which are dissolved bottom of the boiler, we are going to remove that one. So the procedure is first we have to open overboard valve. And second, there are two valves nearby the boiler, sir. One is for throttling, which is very nearby the boiler, and another one is for, outlet valve to the blow down valve. And we are going to open first overboard valve, and after that, the second valve, which is after the regulating valve in the boiler side, going to open those things. And the valve which is one nearby the boiler nozzle, we are going to slowly open that one, and we are going to
So
blow down for.
my question is, which one will you use to throttle?
Sir,
Which valve will be used for throttling?
the valve which is very nearby the boiler, sir.
Are you sure?
Yes, sir. I hope I'm sure, sir. I'll check, sir. Maybe I'm confused with.
Okay. What will happen if you are throttling the? Why we throttle the valve? What will happen if you throttle it?
By throttling, we can control.
The meters, right?
Yes, sir.
Controlling the blowdown. So basically,
Yes,
think over it. Which one will be used for throttling? Okay.
Yes, sir. I'll check, sir.
Okay. Now, have you overhauled any pump on board?
Yes, a screw pump I have overall, and also centrifugal pump.
Okay, centrifugal pump. Which pump? Which centrifugal pump?
Seawater, sir. Main seawater.
Seawater. Can you tell me what procedures you had followed and what were the parts that you had seen in the centrifugal pump overall?
Yes, sir. Sure, sir. Actually, for dismantling centrifugal pump, we have to isolate valves, inlet valve, outlet valve of the pump, and electrically also we are going to isolate the motor connection, lock out target position. We are going to follow those things. And after removing the pump outside, like we are going to check the condition of the impeller and wear ring, impeller casing, the seating of the pump, and O-rings are there. Those things we are going to check. Condition of the impeller, any cavitation mark, fitting marks, erosion, corrosion mark, any foulings. Those things are we are going to check in that pump service. Shaft, so like mechanical seal area, shaft part, key slots. So that distance piece, sleeve, where that mechanical seal is going to sit there. So these all the parts we are going to inspect and check. Yes, sir.
Okay. So what is the purpose of wear ring?
Wear ring. Actually, when the pump is operating, the wear ring purpose is to produce, to protect the impeller, I can say, sir. So if without wearing our pump, we are to run the pump means our impeller getting damaged. So we are going to, if the impeller getting damaged, means we are going to replace the impeller. It is cost too much. So that we are going to fix wearing over there. So instead of impeller going to damage, that wearing is going to damage. So we are going to change wearing. In this place, by changing the impeller, and instead of changing the impeller, we are going to change the wearing, sir, so that our cost is.
Impeller or the casing?
Pardon, sir?
Is it impeller or the casing?
Impeller, we are having wearing on impeller also and casing also, sir. So, but it's maintain small clearance will be there between impeller and casing. So instead of changing impeller or casing, we are going to change the wearing over there. So thereby we are reducing the cost we are expenditure for.
Because seawater is an electrolytic medium, no?
Yes, of course. Yes, sir.
Thereby you have positive and negative. So
yes,
the metals will get deteriorated with the effect of electrolysis.
Yeah, galvanic cell.
Galvanic corrosion. Correct.
Yeah.
That is why you are using a wear ring in a
pump. Yes, sir.
Seawater pump. Okay. Now, what else remaining? Can you tell me what kind of cylinder lubricator was there on board?
Mechanical lubricator were there.
Mechanical lubricators.
Yes, sir. And alpha lubrication.
Both?
No. In my ship, you are asking. Sir.
Yes.
Yeah, in my ship, alpha lubrication.
Alpha lubrication.
Yes, sir.
Can you tell me how the alpha lubricator works? The functioning of alpha lubrication?
Yes, sir, sure. In alpha lubricator, there will be HMA panel, and inside the HMA panel, some ports were there. I haven't recall the ports. Ports will be there. So it will take the input signal from tachometer.
Mm-hmm.
The tachometer will sense the signal from crank angle, and it will give to the CCU of the unit. I mean, in my engine case, there will be CCU. It will give signal to the CCU, and from the CCU, it will going to that hydraulic actuation set. So from the hydraulic actuation, the hydraulic oil will come and accumulate over there. There will be accumulator will be there.
Okay.
So through with the help of that hydraulic pressure oil, this accumulator will actuate accordingly. And there some, I mean, the oil which is going to cylinder nozzle, there will be non-return valve will be there, like a spring loader non-return. So with that valve, the accumulator will
What is that unit called? That non-return valve unit, that is called something.
accumulator.
That is called lubricator unit. Okay.
Okay, sorry, sir.
Lubricator.
Ah,
So the question is, where and all the signal is coming? You said it is coming, speed signal is taking from the tachometer.
tachometer.
Apart from that, whether are other signals also coming in alpha lubrication?
And
So you just need speed of the
Yes.
engine for lubrication, or you also need some other signals?
speed of the engine.
Like earlier, mechanical lubricators were used, which were camshaft control. So
Yes, sir.
that was your camshaft. So it was mounted on the camshaft, and it was taking input from the camshaft.
Yes, sir.
Now you are not connected to the camshaft through alpha lubricator. So what all else you are needing as input signals?
Position of the piston.
Yeah, that is what I mean. That you need something else, right?
Yes,
Crank
sir.
angle, position of crank angle.
Yes, sir. Crank ankle.
For that, what you have? And load also you will need.
Yes, sir. Yeah. For load-based lubrication. Yes, I understand. Load also we need, and position of the piston.
So
also.
from shaft encoder or the angle encoder, you'll be getting the angle. Crank angle.
Yes, sir.
Okay.
Yes,
And
sir.
from the load transmitter, you'll be getting the load.
Oh,
Engine present load. So three signals are there in the alpha lubricator. One
okay.
is load transmission, another is shaft encoder or the angle position, and the third is the one you have mentioned as your speed signal.
Done.
On the basis of that, the alpha lubrication. So basically, they will not ask you on major all details, but concept wise,
Understand. Thank you, sir. Thank you. Understand.
Okay. So I think that is all about the orals. I think you have done fairly well. You are prepared, I think, well about practically also you are aware of the onboard what you have done and what things were there present. And more or less you are aware of your engine type, your vessel specific requirements. So that is okay. Okay, in the boiler blowdown procedure, that question that we had discussed, basically why we are not operating the valve which is just adjacent to the boiler cell, why we don't throttle it. So since you are saying you have to throttle that valve, we will not throttle that valve.
Okay.
We will keep it fully open.
Okay.
Throttling will be done only with the valve which is adjacent to the valve next to the boiler.
Okay. Understand, sir.
Any valve number 2.
Okay. Yes, sir.
So valve number 1 will be always kept fully open. Why we are doing this? There is a phenomena called wire drawing.
Wire drawing, yes, sir. That metal erosion will take place.
Yes, metal erosion will take place due to steam hitting the valve seat or the valve disc.
Okay.
Valve disc. So when you open the disc, you will find there metal cuts are there.
Understand.
Wire drawing has taken place. So if that happens with the valve which is just adjacent to the boiler cell,
yes,
then how can you change it? You cannot change, no?
Of course, sir.
Right, because it is attached to the boiler cell. You have reduced the boiler water level to the lowest possible, and then only you can change it. So when it is in operation, you cannot do it.
Yes,
that is why throttling has to be done always with number 2 valve.
Done. Getting you, sir. Thank you.
Got it?
Yes, sir. Got it.
Okay. Others, I think other questions were almost okay.
Yes, sir.
And gas explosion also you had explained well. Decaf part is good that as a fourth year you have seen these many decaf that you can recall. As I can understand that you can recall from your own good experience and then
Understand.
yeah.
Yes, yes, sir.
Okay, pumps also you are okay with the pump thing.
Mm.
Uh, okay, all in all, I think that is good enough. You should prepare a little bit more about the theory section.
Sure, sir, sure.
Practical
Thank you.
experience wise, MEP part is almost all good. So
Yes,
motor
sir.
part, motor questions, little bit theory part you have to prepare well.
Yeah, understand, sir. I'll do.